Notice, and this is the typical copyright. We continue with Mathematics Syllabus 2018. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and moving forward, with a few pilot projects now being conducted in a few Caribbean countries. The content of the syllabus itself remains unchanged. The two main planned changes to the CSEC level of the math exam are: one, split the exam into two parts, and two, there will no longer be any alternative sections. All sections will be tested with compulsory questions. Schedule of videos: as you already know, these first three sections, all 51 of these videos have been published in their entirety on YouTube, so please make good use of them. From sections 4, 5, and 6, some of these videos have been published in their entirety on YouTube. The others are only partially published on YouTube. We are now at section 7, Relations, Functions, and Graph. This is the 22nd of 26 videos. I am running a little late on this February 26th schedule. Of course, after that, we still have to do section 8, Geometry and Trigonometry, hopefully March 2026. And finally, section 9, Vectors and Matrices, by April-May 2026. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. As I just pointed out, all 33 videos from section 1 have been published on YouTube in their entirety. And that is specifically because this section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. Reminder, you need to know the times tables from 2 to 12, as calculators are not allowed in paper 1. Revisiting section 1, some of these videos are even applicable in primary schools for students, teachers, and parents. In the case of the teachers, they could use it in the inverted classroom, and for the parents who may think that they don't know enough math to teach their children, even at primary school level, this section 1 is actually CSEC work. CXC work at CSEC for math. For example, if you look at this box here, you will notice video 6 says add, subtract, multiply, and divide whole numbers, which is work done in the primary school from as early as grade 2 and 3. And then the next video, video 7, add, subtract, multiply, and divide decimals. Again, that is work done in grades 3 and 2. And of course, grades 4, 5, and 6. But then you look at video 8, and it says add and subtract fractions. And video 9, multiply and divide fractions. Sometimes some students and sometimes some children and even their parents may have problems with those. And then there are other videos down here, like video 11 and so on. Most of these would be work done in the primary school, grade 5 and 6. So there is help here for those students and parents and even teachers at the primary school level who may find it useful to use these videos. As I said, section 2, consumer arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, measurements. Some of these have been published on YouTube in their entirety as indicated in yellow here, and the others are only partially published on YouTube. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, statistics. These 5 videos you see indicated in yellow here have been published on YouTube in their entirety, and the others are only partially published. If you want to have full access to those that are only partially published on YouTube, please see directions in the description below. Section 6, algebra. These 7 videos have been published on YouTube in their entirety, indicated in yellow here, and the others only partially published. Again, the same principle applies if you want to have full access to those that are only partially published on YouTube. Section 7, relations, functions, and graphs. This is where we are right now. This section has 26 videos. Before we go on, recall I said that you will need a good math textbook or maybe a set of 2 to get especially more practice questions and maybe some more explanation. CSEC recommends these that you see here on the right. From those, I will recommend these last 2. Let's see those closer on the next slide. Volume 1, Mathematics, a complete course with CSEC questions by Raymond Tulsi. And this one is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL of that website. On the next slide, I will show you what the home page for that website looks like, which is this. As usual, you would have to register first and then subsequently sign in. This is the URL again up here. This URL will be in the description of this video below, so you can easily click on it and be redirected to that website. Another reminder, this formula sheet that you see on the left here is provided for CSEC examination math papers. It is included in the syllabus, but just in case you don't have a syllabus, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little better. I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as the sheet will be provided during the examination. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So we are back here, section 7, functions, relations, and graphs. We have finished all objectives on this page. And on the next page, we have finished all those objectives. Next page, objective 13, we have finished all of those. Up to objective 17, we have finished all of those. Up to objective 20, we have finished all of those. And now we are here. This objective 21 we completed in the last video. So we are now at objective 22. We are here. After that, we have one more page to go, which will take us to objective 26 in this section, section 7. So as I just said, we completed up to objective 21, and that was video 21. These that you see here from this section have been published on YouTube in their entirety. The others are only partially published. Again, the same principle applies if you need full access to these videos that are only partially published. See notice in the description below. So we are here, video 22. When that is finished, it will be partially published. And this is an overview of how the videos have been, and those that remain to be published will be published in this section. 23 will be published in its entirety, 24 and 25 only partially, and 26 in its entirety. So as I said, we are here at objective 22 in this section. And it reads, determine the equation of the axis of symmetry and the maximum or minimum value of a quadratic function expressed in the form a times x plus h squared plus k. Now, this is slightly different from what we did before, where we were using the quadratic equation. So now we have to look at this equation and derive the axis of symmetry and the maximum or minimum value, and maybe say whether it's maximum or minimum. So first of all, we will review how this form is related to this other form that you are quite familiar with. And we did that in section 6, algebra. Then secondly, we will review how the graph of an equation of the form y is equal to ax squared plus bx plus c can tell us the axis of symmetry and the maximum or minimum value. And we will also see how to calculate that without the graph. And then thirdly, we will determine the equation of the axis of symmetry and the maximum or minimum value of the quadratic function expressed in this format here. It still is a quadratic equation, just like that one, but this is a more familiar format. We will take a look at one example at a time and apply these 3 steps using the first 4 examples, and then the remaining 3 we will move through very quickly. But we will take our time with the first 4 examples to make sure you understand the concept required by this objective. So recall, this was example 1 in objective 15, section 6, algebra. We had to express that form in this format. And we did this already, so I am going to move fairly fast with this. We use this derived formula here, and we eventually ended up with this as our answer. Now, if we expand that, we find that we get back this same expression that we started here. So those are 2 ways of stating the same expression. Also, this equation up here, also this expression here can be factorized to this. So now we have 3 ways of stating the same thing. This is that regular format that we know. This is a factorized version, and this is completing the square version. 3 ways of stating the same expression. This is our example 1 for this objective. So let's convert these two equations and plot them on a graph, or these two forms, that one and this one. Remember, they are the same expression, just expressed differently. If we take some x values as the domain and we substitute those in turn in these two equations, we will get these range values we see over here for the specific equations. If anyone wants to know the formulae that were used on spreadsheet, take for example, this cell here is B4. So we take B4, we squared it, that's this squared. And then we plus 6 times B4, that's plus 6 times B4. And then we added 5, and we press enter, and we get the answer, and we drag that formula down. That's for this equation here. For this next equation here, B4 plus 3, that is x plus 3, we square that, and then we minus 4. And of course, we drag that formula down. So those are the formulae that were used in spreadsheet to get the ranges for those two equations, which gave us this. Notice that the ranges are really the same. So either form, being the same equation written differently, will produce the same graph as we are about to see right now. That's a graph. Now remember, we are still looking at this format because you are familiar with that. And then we will come to that one over there. So looking at this graph, we can find the maximum or minimum value by determining its turning point, which is the vertex. As you could see, it is down here. It is also a minimum value because that is the lowest point that it goes to. And the axis of symmetry is the x value of that point, which is -3. That is what we can determine from a graph. Now we could also calculate that. You don't have to do this, but we will calculate it. The x value of that vertex is -b divided by 2a. And since a is 1 and b is 6, we substitute that and we get -3. That's the x value, which is what we got from the graph. Or if you learned about differential equation from the last video, since the gradient at the turning point is 0, then dy over dx is equal to 2x plus 6, which is equal to 0. You solve that and you get x is -3. That's the x value of the turning point of the vertex. It is also the equation of the axis of symmetry. X is equal to -3. Now to calculate the y coordinate of the vertex, we substitute -3 back into the original equation, and we will get y is equal to -4. So from calculation, using this that you don't need to know at this level for CSEC, we got exactly what we had on the graph. But there is one other thing we need to know. CSEC did not specify if you need to identify the turning point as maximum or minimum when there is no graph. For example, you have the equation and you have this point here. You know that that is the turning point. Is it minimum? Is that the lowest point it would go to? Or is it the maximum? Is that the highest point it will go to? Now to do that, since we know what the turning point is, we can easily find out if that point is maximum or minimum, and this is what you do. You substitute two whole numbers on either side of the x value, which would be -3, in the original equation one at a time. Note if the y values decrease, or increase. So if we substitute -4, remember it is -3 we are looking at, we get y is -3. And then if we substitute -2, we get y is also equal to -3. So let's see what happens here. So the y values from left to right are -3 to -4, that's a little lower, and then back up to -3. Hence, -3, -4 is a minimum value, as we said here. Now that's calculating it from this format. And that's all well and good. But that's not what we are asked to do in this objective. We are asked to derive those things from this format. And it is much easier than what we just did. I just did that, so you will be able to compare that with what we are about to do now using this format. So we looked at that. We looked at this, calculating it. We looked at this from a graph. Now we will use this over here to see if we will get back those same answers. If you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel. So as I said, we did this by calculation. We did this from graph. This. Now let's use this over here to see if we'll get those same answers. Surprise! The vertex y value of that expression is k. In this case, it is -4. So you just look at this, see what k is. Whatever it is, that is the y value of the vertex, which is -4. That value there, -4. The sensitivity here is 2. Sensitivity here is 2, so that would be 2, -2, and the next -2. That would make it -4. So the y value is -4. We got that from the graph. We got that from the calculation that we did previously. Once we get the y value, we want to find the x value of that same point. And that is -h. Just look at this format that you have here, and whatever you have in the h position, make it negative. So we have a 3 here. We'll convert that into -3. So what is the turning point? What is the vertex? -h, k. -h and k. You don't do anything with the k. Just write back the k as is for the y value, and you change the h value to negative. And that will give you the turning point of that graph. -3, -4, which is what we got here. So we know that is correct. Now, is it a maximum or a minimum point?